Hi, this is Hilal. In this video on mathematical economics series, we will solve a question about finding the deadweight loss in monopoly. The question is, a monopolist faces the demand curve, which is Q is equal to 60 minus P, where Q and P are the quantity and prices. The monopolist's total cost of production is also given as, that is C is equal to 1 by 2 Q square. What is the deadweight loss due to monopoly? Okay. So basically we are given a demand function and total cost function of a monopolist, and from that we have to find the magnitude of the deadweight loss. Okay, now to find the deadweight loss due to monopoly, first we will have to find out the competitive equilibrium, that is perfect competitive equilibrium, and the monopoly equilibrium. So for perfect competitive equilibrium, the condition is, so I will write here for competitive equilibrium, the condition is our price should be equal to marginal cost. This is the condition for uh, competitive equilibrium. And for monopoly equilibrium, I will write here for equilibrium, the condition is marginal revenue should be equal to marginal cost. So to get the idea what would be the magnitude of the deadweight loss, first we find the competitive equilibrium, and then we find the monopoly equilibrium, and then we compare the deadweight loss arising out of the monopoly. Okay, so first price should be equal to marginal cost. First so we will solve this very demand curve for price. So this will become P is equal to, if we transpose this P on LHS, this will become positive, and we will transpose this Q on RHS, this will become negative, which is equal to 60 minus Q. Okay, so this is our inverse demand function. Now the condition is price should be equal to marginal cost. So this is our price function. Now to find the marginal cost, we are given the total cost. Total cost is given as, that is 1 by 2 Q square. From that we can easily calculate marginal cost, which is simply the first derivative of total cost with respect to quantity. Okay, so I will write Q here. So we differentiate this very function with respect to quantity to get the marginal cost, so which is equal to 1 by 2 times the derivative of Q square is 2Q, that is Q square should be is 2Q is the derivative of Q square, because this 2 will become coefficient and this exponent is subtracted by 1, so I will write 2Q. Okay, this Q and Q, this 2 and 2 gets cancelled, we get Q, which implies our marginal cost is equal to Q. Okay, now the condition which I have told is for the competitive equilibrium, is that price should be equal to marginal cost. Now our price function is this, so I will write at equilibrium we have the condition price should be equal to marginal cost. So price is 60 minus Q, and marginal cost is equal to Q. Now when solving for Q, we will get, when transposing this Q on RHS, this will become 2Q, which is 60 is equal to 2Q, which implies Q is equal to 60 divided by 2, which comes out to be 30. So competitive output, perfect competitive output, so I will write here C is equal to 30. Okay, this is the output which would be produced in case of perfect competition. Similarly, we can find the price. So since price is equal to marginal cost, we can simply write this, or we can put this Q is equal to 30 in this price function. So I will write P C, that is the competitive price, would be simply 60 minus the value of Q is 30, so we get 30. Or simply, since the condition is price should be equal to marginal cost, and we got Q is equal to 30. Okay, our price would be simply then P is equal to 60 minus Q. We put Q is equal to 30 in this question, in this equation to get the value of P is equal to 30. Okay, so QC is equal to 30. I am using the subscript for perfect competition, and price in case of perfect competition would be also equal to 30. Okay, now so subsequently rather I will show in this slide also the graphical depiction what we got here. So I will also graph this out. Let us say this is our quantity axis, this is our price axis. Okay, now we are given that the intercept is here 60. We can find we can see here 60. So this is our demand function, so I will write this is our demand function. Okay, now perfect competition tells us in this case the equilibrium condition was price should be equal to marginal cost. Our marginal cost is equal to Q, which means it will go through this line from origin. This is our marginal cost function, so this is marginal cost function. Okay, and equilibrium has occurred while Q is equal to 30, P is equal to 30. So the intersection at this point, the equilibrium is 30. Okay, and price is here 30 also, so I will write here this is 30. Okay, now we will find the monopoly equilibrium. For monopoly equilibrium, we have the condition that is marginal revenue should be equal to marginal cost. Since we have calculated the marginal cost, we have to find the marginal revenue only in this case. So which is also easy, because as we know, to find the marginal revenue, first we will find the total revenue, and we know total revenue is simply price into quantity. Now price function is this, so in place of P I can write 60 minus Q, 60 minus Q. Okay, and we will multiply it by Q, so this is our total revenue function. Or we can write it like this, 60 Q minus Q square. This is our total revenue. And marginal revenue, as I told you, is simply the derivative of total revenue with respect to quantity. That means we have to differentiate this very function with respect to quantity. So the derivative of Q is 1, so 60 into Q, 1 is equal to 60, minus the derivative of Q square is 2Q. By power function rule, I will not uh, tell you in detail how to find. I have calculated, rather I have covered all the differentiation portion in my videos. You can also find from that how do we differentiate. Okay, so our marginal revenue is simply 60 minus 2Q. This means the intercept is same and the slope is twice that of the demand curve. Okay, so that means I will draw another line. We have the same intercept of 60 and it would look like this. This is our marginal revenue here. Okay, now we will find the monopoly equilibrium here. Monopoly price and cost, which would be simply, what will we do? I will write at equilibrium. Our equilibrium condition is marginal revenue should be equal to marginal cost. Okay, our marginal revenue is 60 minus 2Q, and our marginal cost is, we have calculated earlier, which is equal to Q. When solving this, this is 60 is equal to transposing minus 2Q on RHS, this will become positive 2Q. So Q plus 2Q is equal to 3Q, which implies Q is equal to 60 divided by 3, which is equal to 3 ones are 3 20s are. So Q subscript M, that is output producer in case of monopoly, would be 20. And similarly we can find the price. So price in case of monopoly would be simply we put Q is equal to 20 in the price function. which is P is equal to 60 minus Q. So I will write 60 minus the value of Q which we have calculated, which is 20. So we get here 40. Okay, so price in case of monopoly would be 40 and quantity produced would be 20. Okay, so we will find here. So equilibrium condition is here, marginal revenue should be equal to marginal cost. Okay, and we got the corresponding quantity would be, so here this very point will denote 20. Okay, so if we draw a perpendicular from this very point, we will get this very point, and this point will denote here, which is 40. Okay, this 40 and this 20 gives us the price of 40 and quantity of 20 produced in case of monopoly. And here in case of perfect competition, the equilibrium condition is price should be equal to marginal cost, and when solving we got price is equal to 30 and quantity is also equal to 30. Okay, I hope I am making myself clear. Now we have to find the deadweight loss. For that, what we can do here, since this is 20, here we can also visualize, or we can comprehend, since the intercept, the slope of this marginal cost is constant, which is equal to 1. Okay, so if here it is 20, if the intersection point is 20, this means here it should be also equal to 20. Okay, the intersection point should be equal to 20, because it goes through the origin, and it has a 45 degree angle with the first quadrant. So if here it is 20, it must be here also 20. Similarly, if it is here 30, which we got here, it is here also 30. Okay, so this intercept, rather this point is to be used for finding the deadweight loss rather. Now what is the deadweight loss? I will rub this. Deadweight loss is rather the deadweight loss is the loss of surplus due to monopoly. First we will find the total surplus in case of the competitive equilibrium. So for that I will put a small dotted line here. Okay, total surplus in this figure we can easily calculate. If we want to find the total surplus in case of competitive equilibrium, it is simply the area of this very whole triangle. As we know, total surplus is composed of two things, that is the consumer surplus and producer surplus. Consumer surplus is simply the area which is below the demand curve and above the equilibrium price. This means that very triangle is the uh, consumer surplus. So if I just try to name them out, so it will become messy, but I will still try to make the things clear. Let us say this is point A, point B, point C. Okay, so total surplus is simply producer surplus plus consumer surplus. Producer surplus in this case is this area, that is, let us say this A, B, C, and let this be D here. Okay, so producer surplus is this very triangle, the area which is below the equilibrium price and above the supply curve, because marginal cost in case of perfect competition is also the supply curve. Okay, the area which is below the equilibrium price and above the supply curve denotes the producer surplus. That means area of triangle BCD plus the area of consumer surplus is simply ABD. I will write, which is ABD. okay, and which is actually this whole triangle A, B, and C. Triangle A, B, C. This is the total surplus in case of the perfect competition. Now, in case of the monopoly, we have the total surplus since only 20 units are produced in case of monopoly and price is 40, so there is loss of surplus in case of monopoly. The loss of surplus is simply this various triangle. So I will show this various triangle will denote the deadweight loss. So if we have A, B, C, D, let us say this is E, this is F. Okay, rather I can write the total surplus in case of monopoly would be the area of this various trapezium AFEC. So total surplus in case of monopoly, in case of monopoly is simply the area of the trapezium, that is AFEC. AFEC. Okay, now the loss of total surplus, which we call the deadweight loss due to monopoly, is simply the area of this very whole triangle minus the area of this very trapezium. This will give us the total deadweight loss. So I will rub this out, and I'm sorry for the external noises which I cannot control here. So dead weight loss is simply area of triangle ABC ABC minus area of trapezium AFEC AFEC. Okay, now what is the area of triangle ABC? It is simply 1/2 of base, so we can take this as base, which is equal to, so here we have the intercept of 60, so we have AC into, and we have the height is equal to dB, so I will write dB minus area of trapezium is simply equal to 1/2 of sum of parallel sides, times height, yeah, or altitude. So we can write it like this. So I will write here, which is equal to 1 by 2 AC into dB. AC is 60, so I will write here 60 into dB. dB is equal to, so we have here 30, so I will write 30 minus 1/2 of, we have sum of parallel sides. In case of trapezium we have AC and EF. Our AC is equal to 60, so I will write 60 plus our EF is equal to, this is 40 minus 20, which is equal to 20, times the height of the parallelogram is here. Simply we can see it is 20. This very height is 20, so I will write here 20. Oh, sorry for the background noises, I cannot control them. So we can solve, this is 2 30s are, so we get 30 into 30 is equal to 900, minus here we have 2 10s are 20. Now we have 60 plus 20 is equal to 80, into 10 is equal to 800. Okay, so dead weight loss is equal to 900 minus 800, which is equal to 100 in this case. So dead weight loss due to monopoly in this case is this very green triangle. So this denotes dead weight loss in this case, and its magnitude is 100 here. Okay, so we can also visualize this. I can show it here. So deadweight lost would be simply equal to area of this very whole triangle. So if I can show area of this very triangle, whole triangle, minus area of the trapezium, which is like this, will give us the area of this very triangle. Okay, I hope I make myself clear in this video. Thank you.